Hello friends, in this video I want to show you what I was doing since the last one. I did made some progress in the wiring, and I was doing some tests in the laser and the calibration. First I will start with the wiring. I'm using this cable. It came with 8 wire, a copper core, multi-copper core. It is flexible and suitable for these mechanical projects. I did run one wire for the X motor through the tube to the other motor, the X2 motor, and both of them through this simple chain, the measure tape trick. Both of them are through the cable chain under the table to where the electronics are. For the Y axis, also run one cable from the motor, the Y2, through the tube to the Y1, and both of them through the cable chain under the table. For the Z, also I use the same cable. I used 4 wire for the stepper motor, and the other 4 wires for the laser module. One pair is for the 12 volt and the other pair is for the TTL signal. Also for the Z axis, I run a wire, this pair of wires to power the spindle, and this silicone hose for the air assistant when I will use the laser diode. I don't think I will need it because the laser diode already have its fan, and it's blow the air from top to the work area. This was for the wires. Just I will show you the technique I'm using. I didn't make the soldering or anything. It's just twisted the wire from the cable and wire from the motor or the end switch. Twisted them together and ran them through the hole and tighten M3 screws over them, so they now stay firm in place. It's a temporary solution. You can see a similar technique in the earlier version of the MPCNC. For the tape drag chain, it's a normal tape measure. It's a normal measure tape attached to this plastic part. This mount, I designed it to fit my 25 wide measure tape. As you see, just mount the tape measure and run the wire and run over them this cable sleeve, and you will get this simple system. It's work for now. It's not the best solution, but it's work for me now. This brackets, I found them on Thingiverse. It's designed for the 40mm aluminum L profile. I'm using this plastic channel, electrical channel for cables. You can see a piece of it here. I just cut one side of it and got the L shape. You can see I mounted the cable drag chain to this arm. I also designed it to fit my 25 tape, and mount it to the XY piece. It's a better place to mount such a thing. Also, you can see this is the module for the laser diode. I was planning to put this module also with the remain of the electronics under the table, but for some reason it was not giving the correct power for the laser diode. It was giving the correct voltage, but not the correct power. So I moved it to this place where the laser diode is attached directly to the module, not through the wire. But the 12 volt and the TTL signal came from the wire, as I mentioned before. By doing it in this way, the laser diode back and work in its normal power. This is for the wiring. I didn't film the wire management. I think everyone has his own way to do the wire management. You can see that I mounted the end stop switch in place for all the motors. I will demonstrate the auto home later. For the belt tension mechanism, it's work perfectly, and I fixed it to the corner part with the M3 screws. Now they are stay in place firmly. For the end stop stop block, I was planning to use one of these. So it's you can see it's very simple to mount it on the belt. The end stop will hit it and trigger, but you can see it stay on the belt. But whenever you will change the tension of the belt, this distance will be changed too. So I changed to this type of stops for the end stops, so the space between the corner and the stop block don't change. For the electronics, first the LCD screen, I mounted it to this leg, and now I'm using a longer cables. It's easy to reach in this place. Also, you can see this is the power supply. I didn't change it. This is some fan, temporary, to just cooling the electronics. And here you can see I'm using the same technique to connect the wire from the cable to the stepper motors and the end stop switch. This is the Z cable. You see the 4 wires for the Z motor connection, and those are the 2 wires for the 12 volt, also came from the power supply. A simple switch to turn on and off the laser diode. This is the TTL wires, TTL signal for the module. You can see the white and the black. They are going to the GND and pin 44. Let me focus here. On the ramps board, in the AUX 2 pins, The GND pin and the pin 44 are used to control the TTL signal for the laser diode, which is controlled by the M106 and 107 command in the G code. Also you see the, if we focus to here, the 10 kilo ohm resistor. I just wired short in the GND and the pin 44. As you can see, this is the Z-Prob, which I connecting them to the Z-mine pins, or the Z-Prob, as you can name them. Two wires you can see, two cable ligator. As you can see, one of them will come to the end mill tip, and the other is to this tin plate. It's the normal type we're used in cooking in the kitchens. I also will demonstrate the Z homing. The laser diode, although I use the 10 kilo ohm resistor, but it's still energized whenever you boot the machine and run for the first time. So keep this switch off, and don't forget to use the goggles every time and let them close to you, because it is energized every time you will boot the machine. By switching it off, it make things safer. Before running the machine, I will show you also the spindles, as I said. Now I mounted it to the tool mount piece with this piece. I designed it, but it's not good as I hoped, because it's hitting this bearing, so I'm losing about 50 millimeter of the Z height. Also the laser diode, it's because my laser diode was an offset in 10 degrees, about 10 degrees, so I made this special to my laser diode. I'm sorry I cannot share this and this to you, because they are made specially to this. Are not good to share it with the community. Also, I want to mention the power supply for the spindle. I'm using this Chinese spindle. Came with the power supply and some potentiometer to control the speed. But because this power supply is giving some noise signal to other electronics, I put it away, so I don't have a problem with the signals. Now I was thinking to make some control panel or some control board and put all the electronics and all other switch together in one box, but because of the noise signal from the power supply of the spindle, I cancelled that idea. I will figure some solution later. I will power the machine and clean the table a little, and we will do some demonstrating for the homing the X and Y and Z, and I will run the laser diode to do some cuts. First I will show you how to get the perfect focal point for the laser diode. Always remember before activate the diode or run the machine, if you don't have this on off switch for the laser diode, don't forget the goggles. It's very important. So for the demonstrating, I will switch the diode on and I will run the machine, and you will see that it's energized while the machine is booting. It's energized for a short time, but it's enough to blind you, so don't forget the goggles. And for that reason I'm using this on off switch for the laser. Back to the focal point. First I will send the machine to the home point on the X and Y. So by going to the custom command and home X and Y, you see that the machine I don't know, for some reason my machine, when it's doing the home for the X and Y, the far stepper motor of the X, it's triggered. As you can see, it's lighting, and both the Y's are triggered. The light is on, you can see, but the nearest the nearest X motor is don't get to the stop block. You can see it still have some place here. So I'm doing the home X and Y again. Go to custom command, home X and Y. Now the nearest X motor has triggered. I don't know, it's maybe because my X and Y tubes are not perpendicular. For that the motor is now facing some resistance from the tubes to get the end stop to the exact point. So this was the home X and Y, and to send the Z to the home position, first we will clip this alligator to the tip, milling tip, and I'll put this plate beneath it, and let's send custom command home Z axis. Now as you see, the machine is trying to get the plate. So it touched it first time, rise up and slowly back and touch it again. So this is the homing of the machine, and by doing that you are now in some position that the axes are perpendicular and all the motors are engaged now. Back to the focal point for the diode. As you see in the information screen, the X and Y and Z are all in the 0 point. The laser diode, as in the descriptions by manufacturer, mine is 5.5 watt, and best focal length is about 50 millimeter above the working surface. So let me move this away. So the distance between the lens and the surface must be about 50 millimeter. So I'm going to use the screen and move the Z to some place which will give me that required distance. Let's move the Z about 10 millimeter first. This is 20 millimeter. By mistake now it's 30 millimeter height, using this ruler. You can see that the length is about 48 millimeter. Let's move the Z axis. So in this point the lens are in the good position. I will put the goggles and run the diode to do the focal point in the finest position. The laser on, back to screen, to temperature and the fan speed. I will give the fan speed 1% of power. So now the laser is on. I don't know if the camera, let me use the other goggle. You can see it's some fine point. I will do some focal the lens and make it the finest point as possible. If you use a black surface, it's better than a white. You can see here it's but now by using this piece of cardboard, we have to take in mind the thickness of the surface. I think this is the best point we will get. but because I did a focal point to surface of this piece, I will measure the thickness of that using this. So it's about 1.2 1.25 millimeters. So the Z is now telling it's about 32 millimeter. Let me drop it down. Move axis Z. So now the Z, after doing the auto home for the table surface, we raised it 31 millimeter, and the focal length, the focal point is in the finest point. So whenever you want to cut any material, you will do the auto home for the z-axis to the surface of that material, and raise the z-axis again to 31 millimeter, and that will be the best focal point for that material. So let me do for this piece of plywood. This is a 3 millimeter thickness plywood. Let's put the laser here. First let's do the auto home. For the custom command, home z-axis. Yes. As the information screens tell us, the Z is now in the 0 position. We will raise it to 31 millimeter. So now the Z in the 31, but if we give the machine the G code to run our job, it will back to the 0. You have to do this command first, to the custom command, and reset all coordinates. By doing that, you did told the machine that this is the zero point for all axes. I have a G code for cutting 20 millimeter square. So let's put the piece of the plywood under the, and this will be the 0 point. Go to the print from media, and this is a rectangle 20 millimeter, and hit print. Yes. I was doing many tests. You can see here. Also here, some many tests for cutting and engraving. For my diode, which as I mentioned, it's a Chinese one, 5.5 watt. I will put the link in the description box below. The best settings was giving the power of 78%, which is S200 for the M106 command. The S200 as a power for the laser, and the feed rate for travel for the cutting was 340 millimeter per minute, which is about 5.7 millimeter per second. And I did cut the 3 millimeter plywood in 9 passes. It take a little time to cut this small piece. As we said, it's about 2 minutes and 8 seconds. So let's see if it cut through. Yes, barely. Still need one more pass, or do a better focal point. You can see it's left some pieces not cut 100%. As I said, those was the best settings for me. And this was the video for this time. I hope you enjoyed it. I will do a separate video for the configuration in the firmware to set the pin 44 to work with the 5 volt TTL signal. See you in the next video. Goodbye.